Hello, my name is Danish Ibrahim. I'm a member of the talent management team at DDS Analytics. Over this presentation, I will take you through a brief overview of the employee attrition analysis we conducted for your company and how we can minimize it going forward. We will also look at models to predict monthly income. Let's go over some exploratory analysis first. Looking at the data, we split it into two groups, categorical and numerical. If we look at the categorical variables, we can see the variables over 18, employee count, and standard hours have only one value in all of the rows. So we can eliminate these from all models. Looking at the numerical variables, we can see that there are a number of variables here that should actually be considered as factors, not numeric. Among these are education, environment satisfaction, job involvement, job level, job satisfaction, performance rating, just to name a few. We'll take these variables and convert them into categorical variables like they should be. Now let's look at the numerical variables and how their correlations are with one another. What you see here is a correlation matrix. This will allow us to see any sort of correlation, strong correlation between one numerical variable with another. If we look at total working years and years at company, we can see that they are both highly correlated with one another. And they are also correlated highly with age and years in current role, respectively. We may look at these later as candidates for removal from the prediction models. Now let's look at the factor variables. Among these, here are the top 5 significant factor variables using chi-squared test as the means to find which variables have the most significant impact on attrition. Overtime, stock option level, job involvement, job level, and marital status. Also using the chi-square test, we can determine which variables do not have much significance. Among these are gender, education, daily rate, hourly rate, monthly income, performance rating, just to name a few. Now let's look at overtime specifically. For overtime, another variable correlates very highly with this, which is job role attrition. Now this makes sense because there are higher ups, your executives, your directors, which are exempt from overtime. Now, if we're saying people that have overtime are able to perform overtime have a higher attrition rate, it would mean that directors, higher ups, who are exempt from overtime would have lower attrition rates, which is what we see here. Looking at the stock option level, we can see that there is a high attrition rate significance with stock option level. However, it's not just positive or negative. There is a relationship in terms of people who have zero stock options have a high attrition rate, but also the people that have the highest stock options, level 3, also have a pretty high attrition rate at 21.82% versus those who have none, which is at 25.86%. The middle two levels are both under 10%. So there is a high strong relationship with stock option level and attrition, but it's not simply positive or negative. Looking at marital status, we can see that there is a lower attrition rate for divorcees versus employees who are married or single. Divorcees have a lower attrition rate at 6.28%, while those who are married have a 14.15% attrition rate, and single employees have a 26.02% attrition rate. Now that we've gone through the preliminary analysis, let's start by creating a classification model to predict attrition. We're going to be using a naive Bayes model. We'll be taking our data set and splitting it up into a training data set and a testing data set. We will build the model using the training data set and test the model using the testing data set. Whichever data set has the lowest root mean square error while giving us at least 60% sensitivity and specificity will be the model that we go with. For model 1, we included all the variables in this model. Model 2, we removed variables that had high correlations with other columns as well as non-significant variables. For model 3, we included all the variables that had a low p-value, which means that they are significant and impact attrition. And in model 4, we did the same thing as model 3, but we removed two variables that we initially saw in the correlation matrix of being having a high correlation with one another and other variables, which was total working years and years at company. Model 4 ended up having the best scores, meaning the accuracy for testing was at 89.7%. It had the best specificity at 92.1% and best sensitivity at 72.27%. This hits all of our numbers in terms of being over 60% while also being the best out of all the models. So this will be the model that we will use to predict attrition. Now let's look at the linear regression model for predicting monthly income. We will be looking at three specific models of linear regression: your forward selection, backward selection, and stepwise selection for building our model. We need to find out how many variables to use, and this can become tedious. So we're going to be using a code that will one by one let in the highest p-value variables into each run and give us the root mean square for each run. Then we will be able to see how many variables for each model is enough in terms of the root mean square being the lowest before it starts going up, which means we need to stop right there. We have to find that sweet spot. So whichever model has the lowest RMSE will be the model that we go with. Simple as that. In terms of all the models, our backward selection model gave us the lowest root mean square error. Looking at this graph right here, you can see at 11 number of predictors, the root mean square error is at its lowest at 977.47. After that, it starts, at 966.12. After that, it starts going up. So therefore, that will be our predictive model in terms of using to find our monthly income. Our takeaways from this project was that naive Bayes should be used for predicting the attrition in our data set. Multiple linear regression, most specifically backward selection, should be used to predict monthly income. Some variables that are seen as numeric should be seen as factors. And employees that are not exempt from overtime are at a much greater risk of attrition than those who are exempt. Many variables can also overlap, so we need to keep that in mind when building models. Thank you for your time, and I hope you've learned a lot from this presentation, and thank you.